All right, we're back with example number 3, but before we get to it, let's go ahead and talk about what congruent angles are. Congruent angles, those are angles that have the same measure. If you look here, we have two angles right here, A, B, C, and D, E, F. And you see how they have these little arcs right there? Those are arc marks. Those mean that those two angles are congruent. So we can say that angle ABC is congruent to angle DEF. Now, if we drew another set of angles, let's say I had something like this, and then something else, like maybe like this or something, and I called this one X, Y, Z, and this one was L, M, N. And I wanted to say that these two are the same. I wouldn't put just one, because when I put one arc mark, that would mean that this angle, this angle, this angle, and this angle, they're all the same. Well, that's not true. These are the same, and these are the same, but these ones are not the same as those ones. So to distinguish that here, what I would do is I would put two arc marks like that. And so the fact that there's two, that lets me know that these are the same, but these are the same, but this group and this group are different in measure. So I could write this. Angle of X, Y, Z, always make sure that vertex is in the middle, is congruent to angle L, M, N. And notice over here, up here, remember how I was saying the measure of angle EOC is equal to 120? When you put a value on it, then use an equal sign, and you use this measure of angle. Use that type of notation when there's an equal sign and a number. But when you're just talking about two figures that are congruent to each other, like these two angles and those two angles, then you just have angle ABC is congruent to angle DEF. You don't put the measure. You only use the measure when there's an equal sign. So there's no equal sign here. This is a congruent sign. So you just use the angle and not the measure of the angle. Okay? All right, so let's move on. We have another postulate to discuss. This one is a very popular postulate. It is not going anywhere. It's going to be around for a while, so get used to this one. Learn this one. This is a flashcard. You need to make a flashcard of this one. So this is a flashcard. Okay, perfect. So this is called the angle addition postulate. Last time I think we talked about the segment addition postulate. This one is very similar. The angle addition postulate, now we're just talking about angles instead of segments. It says if S is in the interior of angle PQR, so here's angle PQR and S is in the interior, then what it says is the measure, and see we're using an equal sign, that's why they have this measure of angle again. So the measure of angle PQS, so PQS, this one, this smaller one, plus the measure of SQR, this other small one, is equal to the measure of the big one, PQR. So this little piece plus this little piece equals the big angle, and that's called the angle addition postulate. All right? So you really, really need to know that one. And this is the short way to write the angle addition postulate, just like that. Angle addition postulate. Perfect. Okay. So let's go ahead and use the angle addition postulate right here with example 3. So it says, using the angle addition postulate in this figure, the measure of angle DEG is equal to 115. So DEG is the whole thing. and the measure of angle DEF, this smaller part, is 48. What we need to find is FEG, FEG. So whenever you see something like this, and you see that there's a part, there's another part, and there's a hole, you should automatically know, hey, this is the angle addition postulate. I'm going to go ahead and write that down. But first, let's go ahead and write down the given information. So the given information, the information that the problem gives us is this right here. So the measure of angle DEG is equal to 115, comma, the measure of angle DEF is equal to 48 degrees. That is the given information. The problem just gives us that. Okay, now from then, now we're going to write, we see that this is an angle addition postulate. So we're going to go ahead and write that formula using symbols first. So we're going to go measure of angle DEF plus, so this angle plus this angle, the measure of angle FEG is equal to the measure of the big angle, which is DEG. And I can say that because of the angle addition postulate. Now from here, I'm just going to substitute in those given values. So instead of writing DEG, I know that's the same thing as 115, so I'm going to substitute 115 in here for DEG. 115 plus the measure of angle FEG is equal to measure of DEG. Oh, did I write this wrong? Oh, whoops. Okay, DEF. This is DEF. That's DEG. So DEF is, what is it, 48 degrees. Oh, man, this is supposed to be 48. I'm sorry if I confused anybody. So DEF right here, DEF is 48 degrees. Okay, we substitute that in for DEF, right? Then we have DEG. DEG is 115. So that's where the 115 goes, right there. Sorry if I confused anybody. So here, we're trying to solve here and figure out what FEG is, which is what they want. So we're going to do the inverse operation of a positive 48. Oh, wait, we did that. That was called substitution. Okay. The inverse operation, which would be to subtract 48 to both sides. And we're left with the measure of angle FEG equals, we do this subtraction. I'm going to have to borrow there. That's going to be a 7. That's going to be a 0, 10, 67. So 67 degrees. So yeah, the measure of FEG would be 67. And if you take 67 added to 48, you should get 115. And yeah, that's true. So there you go. That's how that one works. Let's go ahead and try this again down here. So check it out. Example 3, measure of XWZ equals 121 and measure of XWY equals 59. Find the measure of YWZ. Okay, so we have XWZ. Okay, so that's the big one. And then we have XWY, that's that smaller one. And then they want us to find YWZ, which is this other smaller one. So the first thing we're going to do is go ahead and write down all that given information. So we have the measure of angle XWZ equals 121, comma, the measure of angle XWY is equal to 59 degrees. Okay, so that's the given information. Now we know, because there's a piece here, an angle piece there, and a hole, that this is going to be angle addition postulate. So we're going to go ahead and write that right now. So let's go the measure of angle XWY plus this part YWZ plus the measure of angle YWZ is equal to the measure of the whole thing, XWZ. All right, perfect. And that is the angle addition postulate. Okay, from here we're going to substitute the values in. So XWZ, that goes right here. Okay, so 121 is going to go here. I'm going to write that so I don't mess that up again. And then XWY, the measure of that is 59. So 59 goes here. 59 plus the measure of angle YWZ. And now we just solve and use algebra to figure out what the measure of angle YWZ is. So inverse operations. Oh wait, when I substitute that in, that's called substitution. Then we do inverse operations, which would subtraction property of equality to both sides. And we end up with the measure of angle YWZ is equal to, what was this? So that's 11, that's 2. That was a 1, so 62 degrees. This was the subtraction property of equality, and then we simplified it. So there we go. There's our answer. All right, wonderful job, and we'll see you in a little bit back with example 4.